I'm having fever today, so my energy level is a bit low. So bear with me. I hope I can survive the class today. And look at page 12, guys. Let's go. Okay, right now let's look at your reactive methods here. Okay, so for reactive methods, right, guys, first, please find the mole of given substances. Mole equals to mass over MR. That's the first step. All right, guys, after finding the mole, right, second step, I want you guys to use your ratio method. Okay, using ratio method. Now, please find the mole of desired product. Let's say you have find mass. Mass equals to mole multiplied by MR. That's it. All right, guys, once done, let's try the second question. Come. Magnesium burn in oxygen to form magnesium oxide. Calculate the mass of magnesium oxide. Okay, if 12.015 gram of magnesium is burned under excess. So, guys, my MR for magnesium, 24.3. Oxygen, 16. Can you get that for me? What's the mole of magnesium? I'm getting 0.5 mole. Is that right? All right, guys, let's go. Second step. Okay, I want you guys to balance the equation. Magnesium plus oxygen turn into MgO, right? All right, guys, how to balance the equation? 2Mg, 2MgO, correct. What's the ratio, kid? The ratio is 2 to 2, right? They want you to find magnesium oxide. So this is 0.5. Magnesium oxide is also 0.5. Is that right? Clear? Third step. Guys, please find me the mass. Is your answer 20.15? Yes. Thank you very much, guys. All right, guys, once done, I don't want you guys to do the remaining question already. Can you guys skip to the next page, please? All right, guys, now let's look at the difference between dilution versus extraction. Guys, dilution versus extraction, you need to know when to apply this. So again, for dilution, right? What am I doing? Okay, let me give you one example of dilution. Okay. All right, guys, for dilution, right, just imagine this. Let's say if I have a bottle of wine. Okay, at first the volume here is 100 cm cube. The concentration here, I just put it as 1. Okay, so guys, what I'm gonna do, okay, so no, I think this one put wine macam not good. I think I put whiskey. Okay, hopefully you guys let's talk about some drinking story. So I have a whiskey. Okay, so I have 100 cm cube, 1 mole per dm cube, super duper concentrated. So how people drink it, right? People will pour a glass out. So you pour a glass out. Okay, maybe I pour a little bit like that. Then I add a lot of mixer. So I add water. Then eventually, this is a new, okay, this is your new volume now. All right, guys, now this is dilution. Can you tell me, right, for dilution, what changes? Okay, mole changes, concentration changes, which one changes? Alright, guys, every time you look at the dilution versus extraction, right? When you see the word concentration, guys, in your mind, understand it as how you taste it, how it tastes. Understand? And mole is basically how much you drink. Okay, so guys, again, if I pour the entire 100 out, okay, I add water to make it less concentrated. How's the mole? Will the mole change or not? The answer is the mole is the same. Why? All right, guys. Reason being, I think this one I put as 10. Reason being, you have this 10 cm cube of whiskey. Okay, you drink it or you finish the entire 10 cm cube, you still get drunk, or you pour it out, add water, you finish everything, you still get drunk. Why? Because the amount of alcohol going into your body are the same. You know what I'm saying? All right, so guys, what changes here? So what changes here is our concentration. Get me? So what changes are, guys, is our concentration. So taking in the entire thing, okay, from the bottle, this one, right, tastes very bad. But if you add some water, add some Coke, okay, or it will be a bit better. So concentration changes. And guys, we have this formula C1 V1 equals to C2 V2. This is your dilution formula. This is before, this is after. Guys, this dilution versus extraction, please copy it down. It's very, very popular in your P3. Very popular in your P3. By the way, your senior just gotten back their result. So their result is very fantastic. So which means next year major, you guys are up. Hope you guys can do better. Your senior result is very brilliant. Very brilliant. Muka, you're up next, you know. You have to impress me, you know. Guys, again, my advice to you guys is to really get a tablet. If you guys have a tablet, get a tablet. Next week, bring a tablet. Okay. Okay, guys, now we have abstraction. Okay, guys, for abstraction, very simple. Okay, so abstraction, you just imagine this is a wine tasting. Maybe you guys are underage, you guys don't know what wine tasting is, right? So basically, so I give you a bottle of wine. Okay, so I put it as mole is A. My concentration here is B. And this 50 cm cube. Okay. So for wine tasting, right, you see, you are not drinking the entire thing. You just take a sip. You'll be like, oh, Dad, I want to try how wine tastes like. Okay, so you just take a sip. Get me or not? You taking a sip. So we call it as extraction. Okay, so maybe how much you pour out? You just pour out a 10 cm cube or 5 cm cube. Okay, let me. So guys, in wine tasting or extraction, right? Kid, please tell me what doesn't change. What changes, what doesn't change? Anyone? My physical kid. I think my physical kid is next level shy one, right? Never last week also no one answer me, right? Come, how? So guys, in a wine tasting, okay, what stays the same is our concentration. Okay, the taste after you pour it out and originally in the big bottle is the same taste. Get me or not? Clear. But guys, what differs is just imagine you finish a 5 cm cube or you finish a 50 cm cube. Hey, it's different level, yeah. You finish this 5 cm cube, you can still work out from the classroom, still looking okay. You finish this entire thing, 50 cm cube, you're gonna lie on the floor, get drunk. Why? Because the mole of alcohol you're consuming is different. Get me? So mole changes here. Understand? Please, so guys, if you have question, ask me. So guys, how do you find mole 1 over mole 2? Equals to volume 1 over volume 2. They are directly proportional. If I don't get Alright guys, what's that? I want you guys to flip to next page. Okay guys, I'll show you how does it look like in your actual A levels? Okay, you will have dilution versus extraction question, and it's very difficult. Okay, so one of the hardest questions that you guys will encounter is dilution versus extraction under the same question. Okay, next page. Everyone okay? My online kid, how are you guys? Oh, good. Okay, guys, next page. Guys, NaBnO3, okay, can be used to determine the concentration of Mn2 plus. The RNA equation is shown here. The student used the following procedure in the experiment. Okay, and the procedure is add 10 cm cube. Guys, again, every time you see long question like that with a lot of words, I know your mind will just go blank, then don't know what's going on. My advice is to draw out the process. Guys, you really have to draw out the process so you know what's going on. So I will show you guys how does it go. Okay, so I have 100 cm cube of saturated solution in a volumetric flask. Correct. So guys, I can draw a volumetric flask. Okay, so guys, originally I have 100 cm cube of Mn2 plus. Hear me? Okay, please draw it out together with me. I want you guys to draw out everything. Then we're going to teach you. I'm going to teach you guys how to tackle this question. This question is hard, yeah. All right, guys. After that, add distilled water to make it 1 dm cube. What do you mean by add distilled water, guys? Please tell me the second step here, right? What process you are doing? Dilution or extraction? I'm gonna wait. Thank you, Muka. Oh my God. Love you, man. Okay, so right now, guys, you are diluting it, yeah. To 1 dm cube is 1000 cm cube. Give me a note. I want you guys to put it down. You are doing a dilution here. Get me? Understand? Alright, guys, next. What's next, guys? The next part, kid, you see 25 cm cube of sample, 10. This amount. Guys, what you're gonna do? I'm taking just 25 cm cube of the sample, put into a conical flask. Alright, guys, please tell me from 1000 cm cube to 25 cm cube, what am I doing? I'm doing an. Thank you very much. Guys, please, you have to know what processes you're ongoing here. Okay, so you have extraction 25 cm cube. And guys, eventually I'm titrating against NaBnOH, NaBnO3. Understand? And guys, how much NaBnO3 is needed? This amount is needed. Tell me. Guys, show it out. After that, I'll teach you how to do the next. Alright, guys, what's done? Next. Here, what you're going to do, okay, you have to start calculating the concentration here. They want you to calculate concentration in the saturated solution here. So, guys, this type of question, right, you have to go backward. So, I want you guys to put it as A, this as B, this as C, This has D. Go put A, B, C, D here. Understand? Put A, B, C, D, guys. Next, after you get your everything, just keep counting, just keep finding mole. Understand? Keep on finding your mole. Guys, first, can you find a mole of NaBlO3? What's the formula for concentration and volume? CV over 1000, right? I get a mole already. Is it 2.15 times 10⁻³ ? Good. Alright, guys, once you get the mole of NaBlO3, second, guys, can you get me the mole of Mn2 plus in B? How do you get the mole of Mn2 plus in B? So, guys, you are doing a titration, right? What's the ratio? Mn2 plus to BlO. Let's see this. What's the ratio? The ratio is 2 to 5, correct or not? Am I right? And guys, your BlO3 is times 10⁻³ divided by 5 times 2. How much is it? 8.6 times 10⁻⁴. Is that right? Do your mole ratio, guys. These are the titration calculation. Got it right? Alright, guys, once done. We're done with B already. You see, you found the mole here. You also found the mole here. Next, please find the mole here. How do you find mole of Mn2 plus in C? It's an abstraction, right, guys? What's the formula for abstraction? Mole C over mole B equals to volume C over volume B. Is that right? Understand? Sub inside. How much is it? 40 times 8.6. 344. 0.0344. Is that right? Sorry, sir, I was having connection problem earlier and missed the top part. Oh, no problem. Later I'll show you the top part. It's okay. You copy down this first, huh? Sorry, guys, I'm not feeling so well today. Yeah. Then, guys, okay? Okay, guys, once you get your mole C already, can you get me mole D? What's the mole in D, guys? Let me know. What is this, guys? Please let me know. This is her dilution, right? Will the mole change in dilution? No. Well done. Thank you, Leo. Zero 0.0344. Is that right? Get me. Okay, guys, finally, can you get me the concentration? Concentration is mole times 1,000 divided by volume. What's the volume, guys? 100, right? How is it, guys? So much looking for 3 months. You guys know what is going on? And this question is not easier, guys. Again, my advice is how I make this super duper straightforward is I have a drawing and my calculation is based on the drawing here. Okay, so what I have is the drawing first, then find a mole, find a mole, find a mole, find a mole. I keep finding the mole of everything. Eventually, I'll be getting the answer. Understand? So guys, every time you see questions like that, which you will, okay, please don't be lazy unless you can visualize every processes in your brain, or else try to draw it out to find the pattern. Clear? All right, guys, once done, page 15. Whoever complete that, you can refer to recording later on to copy down the missing part. All right, guys, now what we have is empirical formula. Okay, so guys, what is empirical formula? We call it as the simplest whole number ratio, yeah? Okay, it's always the simplest whole number ratio. Guys, how to find a molecular formula? I have this formula. Molecular formula divided by empirical formula equals to molecular mass over empirical mass. That's it. Guys, to find empirical mass, we use this formula. M square R table mass mole ratio. All good. Guys, next, let's look at the example. 1.55 of gram of phosphorus completely combusted with 3.99 of oxides of phosphorus is produced. They want you to calculate the phosphorus oxide formula. M square table. Phosphorus is here, oxygen is here. Guys, you remember how to do your M square table? Can you try it out first? I give you guys 1 minute. Please get me the answer. Let's go. Done. Okay, guys, let's go. 1.55 of phosphorus. How many oxygen? 2 gram. Correct. Phosphorus MR is 31. Oxygen is 16, 0.125. So the answer is P2O5. Is that right? Alright, guys, remember in our empirical formula, we do not round up, yeah. Do not round up, do not round down. I want you guys to make them the same by multiply or multiplier. Okay, don't round it up, don't round it down, yeah. Alright, guys, I have some time. Can you try question 2 and give me the answer, please? Let's go, question 2. Carbon is 12 grams. Again, all the masses. Hydrogen is 1, oxygen is 16, so it's 35.5. Let's go. M square table, guys. Anyone? Think I can divide everything by 1.27, yeah. C2H3OCl. Answer? A. Is that right? Yes, sir, guys. Yeah, thank you very much. How your empirical formula can, yeah? Okay, guys, if all good, I'm moving on. Can you guys flip to page 17, please? Hi, guys, for chemical equation, that's it. Your reactant and product must have the same number of atoms. You guys can try out to balance this. Guys, next we have ionic equation. You guys know how to write your ionic equation? Guys, I want you guys to highlight this. Split all the ionic compound in aqueous form into ions. Strong acid split. And when you see a covalent compound, do not split up. Solid ionic compound also do not split. First step, you have to write a balanced chemical equation first. Second step is split. Third step is cancel. Last step is rewrite. That's it. Alright, guys, let's go. Magnesium react with HCl, guys. What it turns into, please tell me now. With six symbol. mg plus 2h cell turn into right. Alright guys, next split. How guys? Magnesium cannot split, right? HCl can split or cannot split? 10 right turn into 2h plus and 2Cl minus. Magnesium chloride equals can split or cannot split? Can. Thank you very much, Luca. Answer this with final answer. Done. Clear, guys. Guys, no question. Can you guys look at question 2 and please do it for me? 1 second, go up, can. Wow, 1 second. Okay, Sophie. Up some more. Okay, done. Good. Okay, guys, question 2, please give me the answer. Done. Answer, guys. Done. Thank you, boy. Guys, I'm going to give you the final answer. That's it. Please share your answer, guys. Yes. If no question, guys, let's move on. Oh, good. Nice. Alright, guys, now let's look at identify limiting versus excess. You guys know how to identify limiting and excess? Okay, so guys, first what I'm going to teach you guys is to draw a rise table. This rise table is going to make everything super easier. Okay, so R stands for ratio. Alright, I stand for initial. E stand for N. Alright, guys, done. Alright, guys, now let's look at your rise table first. I want you guys to elaborate on your change. Alright, so the difficult part is your change. So remember, right, the change for product is always plus because product is going to form more and more and more. Reactant is going to get used up, right? So reactant is always minus. Okay, and next, guys, for your change, remember, use your limiting as a reference. Okay, use a limiting as a reference now. Alright, guys, now, how do you find limiting? Alright, so limiting, right, please find the smallest mole over ratio. Okay? So guys, your reactant is here and your product is here. Can see that? Okay, so one side is your reactant, another side is product. Okay, guys, what rise table stand for? Ratio? Okay, so what we are looking for, everything is in terms of mole. Understand? Alright, guys, what's the ratio? 2:1:2:1:1. Is that right? Please write down your ratio first. Sodium carbonate react with this amount of HCl. Guys, let's go. Alright, give me the mole, guys. Let's go. Okay, give me the mole. So I'm a bit confused. Which one? Which one is a bit confused? Okay, let me know. The rise method. Oh, I haven't started yet. I put ratio only 2:1:2:1:1. What happened? Ratio only what? 10. The ratio 10. Just follow the equation only. Initial mole. Guys, give me the initial mole, please. No, I can't understand the one was drawn. You can't understand the one was drawn. Which one? This one ah? You just put in a ratio, initial, change, and this is what we're gonna find. We're gonna fill out the table. So initial mole, sodium is 23, carbon is 12, oxygen is 16. What's the initial mole? MR, right? Understand, guys? Go. How much is it? Hey, the Na2CO3 is here. How much is it, guys? Is it 2 times 10 to the power -2? Correct or not? But guys, what about your HCl? Initially, how many HCl we have? This amount, right? CV over 1,000? 2.5 times 10 to the power -2. Is that right? Tell me. Guys, initially, do you have any NaCl, H2O, CO2? No. Initially, everything is 0. Understand? Yan how? Do you know what I'm doing? I find more only. 10 and 1, okay? Alright, guys, next. Before you do the change, remember the change must be using your limiting as a reference. But which one is the limiting? Guys, first, I want you guys to calculate your limiting first. Alright, guys, for limiting, number 9. Can you guys give me the mole over ratio? 2.5 divided by 2. How much is it? 1.25 times 10 to the power -2. Then this 2 CO3. Get me. So guys, which one is smaller? The 1.25 is smaller, right? Is that right? So which means my HCl is our limiting. I see. And do you see a smaller mole ratio? Please ask me if you don't know, guys. Understand? Excess? Na2CO3. Correct. Understand? Alright, guys, let's look at the reactant for change. Bro, why the ratio don't apply to when you finding mole? When you find mole, you don't apply the ratio one. We'll find mole, right? Mole formula is just mass over mr CV over 1000. You don't take the ratio. The ratio is 2 HCl react with 1 Na2CO3. When you find mole here, though we don't care about the ratio one, we don't use ratio here, you get me or not? So, okay, next, guys. For the change, remember reactant is minus, correct or not? Product is plus. Understand? And guys, we always take our limiting as reference. So which means HCl is our reference. So which means all the HCl gonna react. Get me or not? Understand? Alright guys, this is the ratio of 2. So any ratio 2 is the same value. Get me or not? Alright guys, what about ratio of 1? This value representing 2. If it's 1, divide by 2. And all the 1 will be having 1.25 times 10 to the power negative 2. Get me? Understand or not? Good. Alright guys, at the end of the day, we do N mole. N is initial plus change. 2.5 minus 2.50. 2 minus 1.5, 7.5 times 10 to the power negative 3. 2.5 times 10 to the power negative 2. That's it. So all the mole got it already. Understand? Yeah. So guys, now I have everything. Can you get me B, C, C, D, E? Get me the answer for C, D, E, please. C, D, E now. Done. Alright guys, let's go. What's my DEF? What's my part C? Mole of NaCl form. 2.5 times 10 to the power negative 2. Gram of NaCl form. 1.46, is that right? Next, gram of excess left behind. Mole left. Is that right, guys? And please check out, guys. You see, with the rice table, do you see that everything is kind of easy? Everything is gonna fall into places for you guys, huh? Clear. How good? All right, ready? Okay, guys, let's go. Page 22. Let's look at water of crystallization. Okay, guys, for water of crystallization, right? Okay, it's when you have H2O chemically combined with the salt, yeah. So we have hydrated, okay, copper 2 sulfate, CuSO4 5H2O, CmgCl2 6H2O. Water is necessary for the formation of crystal. It's known as water of substance that contains water, we call it as hydrated. No water, we call it as anhydrous. That's it. Clear. All right, guys, what I want you guys to do, you just have to write down the equation. For example, if it's MgCl2 XH2O, you have to write it down as okay, so you can write down the ratio 1 to 1 to X like that. Clear. Good job, guys. Next. 2.56 gram of hydrated sulfate, 1.25 gram of anhydrous is formed. All right, guys, next question. Let's try. All right, guys, again, I can write down the equation first, how you see. 1 to 1 to X. All right, guys, first step, what is my mole of MgSO4? Get me the MgSO4 first. Second, all right, guys, once you have the MgSO4, second, I want you guys to get me the mass of water. Okay, how do you get the mass of H2O? It's equals to your hydrated, the wet one, minus of anhydrous, right? The dry one, right? Okay, you get 1.31. Let's start. I get 0.0728. Is that right? 10. All good, guys. Last step, do the ratio. Mole of H2O divided by mole of MgSO4. 0.0728 over 0.0104 is also equals to x over 1, right? So what's x? 7. Done. Now find your hydrator, yeah? That's it. Understand? Any questions so far? All right, guys, please write down. Next. We are moving on to another part. All right, guys, can you guys flip to page 20 and question 2? Okay, guys, today is our last class doing chapter 1, yeah? Next week, I'm going to move on to chapter 2 already, okay? So I want you guys to look at page 20, question 2. Let's grind this question together. Formula of malachite is this amount, yeah? 12 gram of malachite is added into 30.01.5 nitric acid. Which mass of malachite is left unreacted when the reaction is complete? Okay? Guys, what I want you guys to do, I want you guys to balance the equation first. Come. Copper hydroxide, copper carbonate. You get 2 CuNH32. Okay, CuNO32, because one copper will react with 2 nitrate to turn it into CuNO3. Then you have another copper, then you have 2 CuNO32. Then all the H2 will turn into, all the CO2 will turn into, all the OH will turn into H2O, all the CO3 will turn into CO2. That's it. All right, guys, I gave you the balance equation already. There you go. You can do your rise table if you want to. Please try, guys. Your balance equation is here. I just want you guys, if you're not so sure, you can apply your rise table. Try again to do it on your rise table. Let me know what's your answer, guys. So, guys, basically, your nitric acid is the one that is limiting, yeah. Okay, answer, guys. Anyone? Ratio is 1 to 4, correct or not? Mole. All right. All right, guys, I know that this is limiting, yeah. So you have to minus off everything here. Finally, you want the mass of unreacted, right? My mole of unreacted is how much? This is my mole of unreacted, correct or not? So take the mole, multiply by MR, right? Final answer? $9.51. Is that right, guys? Know how to do, Sure. Yes, please copy down, guys. After that, question 1. Try Q1, guys. Q1 is harder, Sir, can you explain the change now? I don't really understand the part. Change, is it? Alright, guys, the change, right, we always use reactant as minus. Remember, reactant is always minus because this is my reactant, right? Product is always plus. Okay, then the value that we use, we always use limiting as the value. We always use limiting as a reference. So limiting is here, right? I just put my 0.045 is here. Let me know. So 0.045 is representing ratio 4. What about ratio 1? Take this divided by 4. That's it. Understand? And remember, reactant is always minus, product is always plus. This amount of As2O, okay, placed in this amount of pure oxygen. Okay, reactants are heated until no, the reactants are then allowed to cool. Calculate the volume of gas present at the end of the experiment. Yeah. Guys, you know that oxygen is in excess. That's it. Guys, again, if you don't know what to do, do your rice table. Trust me, once you get your rice table out, it's damn easy. Do your rice table, please. I'm not going to guide you first. I want you guys to try your rice table first, please. That will be your last time to try out with me already. Alright, guys. Alright, guys, if you're not so sure what to do, guys, come, rice table. Okay, guys, the ratio is 2:9:1:6. Guys, I know that this is excess. Can see that oxygen is excess, which means As2S3 is my limiting. Understand? Clear. Go. I'll wait until one of you guys get answer, then I'll discuss. Please try, everyone. What's the answer, guys? 0.81. That's the final answer. Okay, thank you, Jiang. Okay, since Jiang got the answer, I'll discuss. Yeah. So, guys, again, 0.198 gram of astatine divided by mR. What's the mR? 74.9. 8.055 times 10 to the power -4. O2, right? How much O2 we have? 0.1 gram. Room is 24, right? Initially, you have no product, you have no SO2, correct or not? Am I right? Clear? Okay, guys, which one is the limiting? This is limiting, right? So always remember my reactant is minus, product is a plus. Guys, this is representing ratio 2. How to find ratio 9? This value divided by 2 times 9. Divided by 2 times 1. Alright, guys, can. So at the end of the day, you have no more AS2, S3 left. You have 5.47 left. And this one left, is that right? Alright, guys, finally, the 1 mole of volume of gas, So guys, please tell me what is the volume, the mole of total mole of gas formed? Is equals to the mole of oxygen plus mole of SO2, right? And finally, guys, how to get the volume of gas remaining? Zero 0.071. Done. I think your answer is 0.081. Okay. Your value is a bit 7 or 81. Sorry, sir, can you clarify once more how to identify limiting and excess? Boy, read the question. They already tell you, right? Oxygen is excess. You see or not? Oxygen is excess. So O2 is excess. Huh? So which means this is limiting. Understand? So one. Correct. Okay. Guys know how to do. Guys, okay, this is considered one of the very difficult calculation question. Next week onwards, we are moving on to chapter 2 already, guys. You will see how in chapter 2, chapter 2 is quite difficult. Okay. So guys, I'll see you guys next week. We are doing chapter 2 next week. Please don't skip the class. If you can't make it, please refer to recording because chapter 2 is very important. Okay. I'll see you guys. Any question, you can stay here and ask me.